Welcome everyone to another lesson on Khadija Academy. Before we start this lesson, hit the subscribe button, the notification bell, and the like button for the YouTube algorithm. Now let's go and start our lesson. Hey everyone, in this lesson we will start discussing how can we estimate the phase or angle of a grid voltage. So in the previous lessons we learned about vector control and scalar control. And in vector control we said that we are going to use a phase locked loop in order to get the theta, which is used for transformation, right? We said before that we have our reference like this, and we have vector VBCC with an angle theta, and we would like to find theta here in order to make ID, or make the axis, to be more specific, the axis on it and the Q axis at 90 degrees from it, right? The axis oriented on VBCC. That's why we need this angle for transformation. So we will discuss the different methods. Number one, how can we estimate this angle? The first method is by using the phase voltages, or to be more specific, by transforming our three-phase voltage into alpha beta frame, and then we can get the angle. How can we do this? Let's see right now. So by using the alpha beta stationary frame, we can represent our system like this. We have the three-phase grid voltage ABC, VA, VB, VC. We will use ABC to alpha beta transformation, ABC to alpha beta, and remember, here I'm using the power variant transformation. Why? Because I'm not caring, or I'm not considering the power. What is important for me is the magnitude of these voltages. Okay, I'm looking for the magnitude of the voltage, as you will see right now. So we use the power variant transformation. Now what you will find that is that by using this you will have two components, V alpha and V beta, which is alpha beta voltages in the alpha beta frame, or the components of ABC in the alpha beta frame. Okay, now by using these two quantities, as you know that these two quantities representing the three phase, right? So if you take the magnitude of V alpha and V beta, you will get the magnitude of the grid voltage, root V alpha square plus V beta square. If you remember that when we had alpha and beta, and when we have the rotating vector, VG or VBCC, whatever you would like to call it. So this one was rotating, right? At every instant there was a component here on, which is V alpha, and another component here, V beta. So at any given instant, at any instant of this vector, it will be divided into two components, one on the alpha frame and one on the beta frame. These two components together as a phasor will form our VBCC. So our VBCC, if you remember, is equal to, or our VG, V grid, as a magnitude, before as a magnitude, VG is equal to V alpha plus J V beta, right? So if I would like to get the magnitude, it will be root the real part square plus imaginary part square, right? Which is exactly this equation. If I would like to get the angle theta, look carefully at this diagram, which is the angle of this vector. Tan theta is the opposite, which is V beta, divided by the adjacent, which is V alpha. That's why if I would like the angle, it will be tan minus 1 V beta over V alpha, which is exactly this equation. So again, this vector is the resultant of VA, VB, VC, and it is rotating with omega s, the angular frequency of the system, 2 pi multiplied by the frequency. Okay, Okay, and you will find that at any instant it has this angle theta which is used in the transformation. So by getting V alpha and V beta, how can I get them? By using this transformation from ABC to alpha beta using the three-phase voltage measurement transformation, get alpha beta, and using this alpha beta you will get angle which is needed, and you will get these two components, right? V alpha and V beta, and you will not need them right now. We don't need this part. What we all need is theta from here, which is used in Parquet transformation in the vector control. Now, what exactly is the problem here? Okay, I will tell you what is the problem. Number one, if we have harmonics or if we have noise on these signals, when we measure them, there can be some noise which is on these signals, right, which can make V alpha and V beta wrong, making this angle also wrong. This is one of the first problems, that these can have noise in the measurement, leading to alpha beta being inaccurate, leading to inaccurate estimation of the angle, right? That is the first problem. Second problem is that you will find that at some instant, when this one is rotating until it reaches here, for example, at this point, you will find that V alpha is equal to 0, right, at this point. So you will see that 10 minus 1 V beta over 0. And this can cause some errors inside our computations or on our algorithm or on our PC. Okay, this 0 here causes some issues. Okay, that is another problem. Now, how can we solve the first problem, which is the presence of noise here? Okay, so in order to solve this problem, we will use some digital filters. These are used in order to avoid disturbances due to noisy measurements. And of course, we need, since we are going to add a filter, we need to compensate for the phase error introduced by our filters. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You can join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits. You will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics.